Hi, and thank you for joining us today. This is Digital Identities, 21 PKI Pitfalls, and how best to avoid them. I am Tim, the Chief Compliance Officer at Sectigo, and I'll let Jason introduce himself.
Yes, my name is Jason. I'm the CTO of PKI at Sectigo.
And Jay and I do this sort of thing together a lot because we do have a PKI podcast, a rather long running at this point PKI podcast. So we'll talk about that a little more in the end. But if we feel like we have had these conversations before, it's because we've had many, many conversations before. So we do look at a lot of PKI. So Sectigo is a leader in the PKI space. We have a variety of tools. We offer certificates, and we also offer certificate management tools. And as a consequence, we deal with a lot of enterprises that are either creating or using PKI, and we get a lot of visibility on the various ways that things can go right and the various ways that things can go not so right. So what we hope to today is just talk you through the PKI errors we see, the common pitfalls, explain what they are, and maybe how to be on the lookout for them and what to do about them. Does that sound good, Jay?
It's good, Tim. Thank you.
So we divided this into 5 different kinds of problems. You can see them right here: certificate problems, deployment problems, security problems, governance problems, and visibility problems. And we are going to drill down on each of these types of PKI pitfalls to avoid. So first off, there we go. Here we go. So those are the 5. So first off, certificate problems. Jay, problem number 1, weak keys.
Yes, Tim, you and I talk a lot about on our Root Causes podcast, the whole idea that there are specific key lengths that are chosen in the industry. Mm-hmm. And unless you have a sufficient amount of entropy, the sufficient amount of bit length within that is chosen with your keys, it might make it a little bit easy to hack. And therefore, you should really go with industry standards, industry best practices. Weak keys are something you should look for, have visibility to, and try to avoid at all costs.
And these numbers do move. They don't move very often, but if you have, if you're a gray hair like Jay and I are, the key length that you believe that was acceptable 20 years ago when you started in your job may not be acceptable anymore. So it's a good idea to make sure that you're with the current practices on that. And then, of course, the problem, if they do have weak keys, the trouble with that, Jay, is?
The trouble is it kind of depends. If it's publicly trusted certificates, hopefully you're getting it from a certificate authority that is obviously using the correct key lengths, RSA 2048, ECC 256, etc. Typically where you're going to see problems with weak keys, though, Tim, is in privately trusted environments, IoT, perhaps even DevOps. So that's a situation where somebody who might not be a PKI professional might have chosen incorrect defaults, and that's where you're going to see more of the problems more commonly.
Yeah, the public CAs are going to take care of a lot of these for you, and maybe we can clarify which ones they do and don't. But this page is going to be pretty much okay for the public CAs because they can't give you these certs. It would be against the rules. But when you control your own PKI, you get to do whatever you want, right? So that's where a lot of the certificate problems are going to come from. The second one on the list, the term is too long. So in the public certificate space, depending on the certificate type, if it's an SSL or TLS certificate, you're limited to 1 year, essentially 13 months. If it's an SMIME or code signing certificate, it's limited to 3 years. But once again, if you're issuing certificates on your CA, you get to do whatever you like. And one of the things we see sometimes is someone says, oh, this is great. I'll issue a cert. I'll make it 20 years long and I'll never need to worry about it ever again.
Tim, for terms, especially again in the private trust world, which is mostly where I live, it's quite common now to see much shorter and shorter terms being chosen. For 2 reasons. One is because it just flat out, it makes the difficulty level of the bad guy easier if you don't have a very long-lived certificate. Sure. If a long-lived certificate is captured by a bad guy, that bad guy has a long time then to go doing bad things. So therefore, shorter and shorter term lengths are becoming more common. That requires certificate management, of course, but that's part of what modern PKI is going to be promising us.
And we'll be getting to that, I'm sure. Right. So just by reducing certificate term, you reduce the potential attack time, right? Pure and simple. There's only so long that you can work on a cert before that cert doesn't matter. Outdated cryptographic algorithms. So once again, as with key links, these are things that do evolve over time. Once upon a time, SHA-1 was considered to be state of the art. Now SHA-1 is deprecated. It is considered to be unsafe. And these, and we'll come up on the fact where RSA and ECC will be considered to be unsafe. That's not that many years away. So cryptographic algorithms do change, and you need to stay current. And we still see people using SHA-1 still.
Yeah, so we're mixing a few things there where the primitives, right? So hashing algorithms are the ones where deprecated cryptographic algorithms are the things that we've seen quite commonly in the past, and we've had to deal with them. Again, visibility of the certificates that you're issuing and using is incredibly important, because just like you don't want to use a weak key, you do not want to be using an outdated cryptographic algorithm, whether it's for hashing or anything else. Once again, though, in the public world, the CAs are typically doing this thinking for you, but it's when in the private world where you're having to do this thinking yourself, where it's quite easy to make mistakes. Yeah,
for sure. And then certificate stapling. Oops. Talk to us about certificate stapling, Jay.
Sure, Tim. This was a big topic. I think mobile devices are where this really came up quite a lot, where certificates were used in mobile apps. And it was quite common for applications to hard code public key information. And unfortunately, applications don't get updated as often sometimes as need be to be able to keep up with perhaps a revoked certificate. And so therefore, something happens in the background, all of a sudden that application, unless it can be updated to the whole world very quickly, you're going to have a major problem. And so therefore, certificate stapling, there's other ways that this has been put, but essentially the risk here is hard-coded public keys within applications.
Yeah, and it may not be quote unquote stapling per se, but I mean, I was just this morning talking to a major enterprise who had hard-coded applications look for specific details inside their certs, and those details were changing, and they had to create a roadmap item to deal with that.
You should consider all certificates ephemeral, period.
Yeah, absolutely. That's a big one. And you lose your agility, right? We're going to talk about agility, the ability to change out your certs and swap out your certs when unknown events occur or unexpected problems occur is a major part of the robust, high uptime, high security contemporary enterprise. All right, deployment problems. So those are certificate problems, deployment problems. First of all, reuse of certificates. We see this a bunch.
Yeah, Tim. So I think in the public trust world, there are examples of if you have multiple servers that are handling a specific domain, you might be doing a reuse of a certificate. I'm not sure if that's the worst thing in the world, but I will tell you one of the big problems with a reuse of certificate in the private trust world, again, is the automotive industry had a problem with this, with their key fobs, where there was a practice of using the same certificate, just copies of certificates in all the different key fobs. They were not issuing different certificates. And so therefore, if that certificate were to be stolen or by, some sort of process, especially because the risk there is the fact that every single certificate was just, within a physical device that was so easy to steal. Unfortunately, it caused a situation where that key fob could then be used against a number of targets at once. Reuse of certificates, not a good idea. Issue a certificate per destination.
Yeah, and in an IoT scenario in particular, right, one of the problems, of course, is oftentimes there is no replacing that certificate on the device, right? If you revoke the cert, you brick the device. And so under those circumstances, you want granular control, right? If there were a reason why I had to get rid of one cert, brick one device, it'd be a shame if I had to take 10,000 of its closest friends with it, right? But that's a real scenario that really people run into in the real world. Now, on the public trust side, certificate reuse, this is a tough one because on the one hand, I get your point, and this comes up where people say, look, I have a cluster and I have to manage this, and it's putting an individual cert on every individual machine or VM is very difficult for the following reasons. Yeah, but what you're doing again is you're extending your risk. In the hypothetical scenario where there is a search that needs to be got rid of right now, or in the hypothetical scenario where somebody steals a private key and you don't know it, if you have it on one machine, your risk is more limited. If you have it on 50 machines, your risk is much broader. And so that's a problem.
They call them leaf certificates for a reason. Every leaf should have a unique identifier.
Yeah, so it's tough. I understand the temptation, and probably right now some of you in the audience are going, well, but I really got it. I get it. But you also have to understand that you are extending your risk of outage or worse. As the more you reuse certificates, the more you're extending that risk. And so I guess what we're probably saying is keep that to a minimum. Do it when you must. Don't do it when it's more convenient. And that's actually kind of a theme for the next two, right? Overextension. And 6 and 7 sort of go together. They're two flavors of the same thing. It's overextended use of a specific certificate. So just like when I copy a certificate and put it on multiple machines, I also can say life is easier if I use wildcards because they work with more domains, or life is easier if I use MDCs because I can take the same certificate and can work with more domains. And that's important. They're important tools in the chest. That's why they're there. But on the other hand, you can be too enthusiastic in your use of these things and you can overextend.
So, Tim, a perfect example that I can think of from a bad guy's perspective, wildcards are great if you're attacking that site because the ability to create subdomains at will is quite easy. And
right. Sure.
So therefore, convenience to the person, the convenience factor to the victim was great. All of a sudden, it's not very convenient once you find out that your sites are being used for phishing.
Yeah, and also, once again, this extension of risk argument, it's just like reuse is the same. In the event that there is a problem, instead of losing a more limited part of my service infrastructure while I deal with the problem, I'm losing a bigger part of my service infrastructure, right? More problems, more cascading effects, more outages, more customers can't be served, more employees can't do what they need to do. So again, it's like reuse of certificates. I know the reasons why people do it. Those reasons are valid. Our environments are technically complex. And at the same time, just be careful about being lazy about it and make sure you're doing it because you must and not just because you can.
Yeah, well said.
All right, we already hinted at this one. So automation, a big one we see, failure to automate certificate renewal. So in the public trust world, all of your certificates will expire. They will expire by a certain time frame that's not that far away. Normally, the certificates last longer than the services that they serve do, and that means certificates need to be renewed. And when they aren't renewed, there are outages, bad things happen. A couple years ago, the O2 data service went down. O2, SoftBank, and other providers went down. Maybe 40 million people were without phone service for most of a day. The root cause was an expired certificate that didn't get renewed. The Equifax breach that affected 45% of Americans, myself included, was enabled by an expired certificate that didn't get renewed. Every year we see high-profile outages from major technology providers and major online services that go down, and the root cause is a certificate that didn't get renewed.
The list goes on, and these are not minor players. We're talking about Microsoft Teams.
Yes.
Sony had an outage. The list goes on and on. And what's interesting, Tim, is we were waiting for the first big example of this in 2021, and we've now seen it as well.
Yeah, exactly. So automation of certificate renewal is key, and in the again, a lot of us, especially the old timers, remember once upon a time where I had a room with a drop floor and there were exactly 23 servers in it, and they had to be swapped out once every 2 years. And it was easy to put things in your calendar, but that just isn't our world anymore. And if you're still trying to do these things manually with spreadsheets and are getting more and more complicated, this is how people get in trouble. Automation of renewal is so valuable.
Yes, sir. I'm thinking, think of the proliferation of web servers, the proliferation of load balancers, the proliferation of all the different places where your certificates are renewing. That's just in the public trust world, never mind the private trust world, where they can be in hundreds and hundreds, if not thousands of locations.
Yeah.
This has to be automated now. It's 2021. It's going to be 2022 soon enough. We've got to, dealing with it by spreadsheet, we just have to get rid of that.
And then this ties into your earlier point about shorter terms, right? If you want to shorten your terms, then automation becomes all that much more important, right? If I take my certs and I say instead of 1 year, I'm going down to 90 days, I just quadrupled the number of renewals, right?
That's right, Tim.
And so I better make sure that I'm able to deal with it. The next two also in a way kind of go together. So multiple private CAs. So here's the scenario. Somewhere along the line, I need a CA, and so I go and I put something together and I put it in place and I set up and I run with it. And then somewhere on the line, someone else in my organization, they need some in-house certs, and so they make their own CA, and et cetera, and et cetera. And suddenly I have all these CAs out there, and I have all these routes, and I have all this stuff to be managed. If I don't get all the right routes and the right machines, then systems don't work, and it can become an administration nightmare.
Tim, here's a pro tip for you, and for anybody who's watching this. Every Kubernetes cluster has a CA.
Right.
Anybody who's doing DevOps, raise your hands virtually. You have CAs that are proliferating within your environment that you might not know about. You might say to yourself, this doesn't apply to me. I've got a great governance program. I've got a risk officer who's obsessed over this. Yeah, but you probably have a DevOps team that's creating CAs and you don't even know it.
Yeah. Absolutely. And again, the disadvantages of having multiple CAs run around, it's less efficient. It is much harder to maintain consistent compliance with your own government rules. There's more things you need to look at. And there's the potential for systems not to work correctly, not to connect to each other correctly, because, I was expecting one CA and I was getting a different CA.
Tim, I would say this is an example where we don't often in the PKI industry talk much more about trust models. We used to back in the old days.
Oh, yeah.
But I think it's got to come back as a conversation. And that's where going to the experts really helps, because we've seen it all, been there, done that. And there's a sweet spot for every use case and every scenario. And there's a sweet spot for the growth that you're going to have within your enterprise as well, especially out to the cloud. Dealing now with extending trust to partners, multi-vendor ecosystems. There's ways to determine how you should structure your CAs.
Okay, fair enough. And probably we can't get into that now, but that might make a good podcast or a future webinar. And then connected to that is maintaining an unnecessary Microsoft CA. So again, what happens here? What happens here is I have a Microsoft CA. I've had it for a long time because I've had Windows servers and Windows machines. And my operating system makeup has outgrown that, right? It's more heterogeneous than it was at the time, but we've still got this old Microsoft CA sitting around that's only good for part of what it needs to service, and then we have to service everything else with a different CA, but we don't rip out the Microsoft CA just because it's kind of always been there.
Well, Tim, my hair is quickly graying, and that's just proof that Microsoft CA has been in my life for a long time. I've seen a lot of implementations of it. What used to be a very Microsoft-centric, siloed enterprise environment has now quickly grown to be extend to the cloud, You now have multiple operating systems, not the least of which is Android, iOS, etc., on and on and on, various flavors of Linux, mobile device use cases. All these things did not exist in the heyday of Microsoft CA.
Right.
And it has not kept up. And Microsoft has basically left it to the industry to deal with that. And so therefore, you really have to question, should you be, at the very least, you probably have to be augmenting your Microsoft CA.
Yeah.
But on the other hand, are you keeping it just because it makes you feel warm and fuzzy? It's one of these things where that free CA has cost you a lot of money over the years with the difficulty of maintenance. PKI has moved on. It's good to look at what's out there to be able to replace it or to augment it very well.
Fair enough. All right. So the next one, security problems. Good old-fashioned things or security and vulnerabilities with your certificates and your keys. So first of all, inadequate protection of your private keys. Private keys are what it's all about. If anybody gets the private keys, the certs are no good. So talk to me about this, Jay.
Sure, Tim. I'll use an example that's probably very easy to relate to for most people. But how many of you know for a fact that within your organization, your SSH keys, not necessarily your PKI managed keys, but just your SSH key pairs are sitting around. They're just on somebody's file system, and when you need them, you use them.
In a folder called keys.
In a folder called Hack Me Now Here.
Right.
Unfortunately, that's incredibly common. So if you enter then the PKI version of that story, it's exactly the same scenario, which is obviously for your CA root keys in a private CA scenario, you should be putting those in an HSM. But for Leaf certificates, for example, we now have all sorts of secure elements available. All Windows 10 laptops come with a TPM. There are various other form factors to protect your keys. So regardless of whether they're root keys or whether they're Leaf certificates, these are things that in the modern age now, we can protect things properly. And that even includes IoT. I still see a lot of IoT devices where the certificates are stored in software. There are very cost-effective secure elements now for IoT devices where the certificate can be stored in a very, very secure location, isolated from the main kernel, isolated from the user land memory. You got to check into these things.
All right. And then patches and vulnerabilities, right? Patch management. So, if you're using a third-party service, a SaaS service, like for your PKI, for instance, that vendor is going to take care of this. They're going to make sure everything's patched and current. They're going to make sure that, they know about the 0 days on day 0 and that they respond for them. But if you take it and you kind of set up your own PKI and somebody puts it up and it's running and everybody forgets it and it's sitting in the background, who's keeping an eye on that? Who's making sure that you're current? Who's making sure that you don't have holes that have been discovered that you could have patched, but you didn't because nobody thought about it or nobody thought it was their job?
I think it's very common. And Tim, I remember during the last set of overwhelming difficulties in the industry for everybody in IT, that there happened to also be a Patch Tuesday to patch other things at the same time. And all these things, unfortunately, have to be tested in a lot of organizations before the patch is allowed. And so these dependencies of patching leading to long lengths of vulnerabilities being wide open. It's a golden age to be a bad guy right now.
It is. It is. So that's another, again, that's a common one we see a lot. Governance problems. So first of all, just go old fashioned. Oh, we don't have rules. We don't have rules for our certificates. We don't have rules for PKI. Is that a thing? Now, again, not so much an issue for public certs, although even then you might want to say, look, we're an ECC shop or, things along those lines. But in the private PKI world where you can turn the levers any way you like, it can. We've seen it where it's just absolute chaos.
Chaos to the point where, if you go back to some earlier slides, Tim, SHA-1 certificates aren't even
Right.
part of the policy. So in other words, issuing anything you like is kind of a possibility, and
Right.
nobody's got the visibility to it. So, I think we'll be talking a little bit more about visibility later, but governance plus visibility together are incredibly important.
Yeah, and also remember that a lot of the people involved in your organization are not the PKI experts. They are expert in something else. They're great developers perhaps, but they don't know really anything about PKI. And so if there aren't policies for them to follow, if there isn't a recipe book that you give them, then they're forced to try to figure these things out for themselves. And they may not be the best qualified people in your organization to do that.
It's hard enough for a full-time risk officer in
Right.
a normal size organization to do it. Never mind leave it to people who are,
Yeah.
that's not their full-time job.
Someone who's overworked and busy and on deadline and supposed to be doing something else, and they have an internal customer who's screaming at them. Yes, exactly. CPS problems. So once again, is there a CPS? Do you know what it says? Where did it come from? Was any consideration built into it? These are all legitimate questions.
The big question to me, Tim, is did it lock you into something that doesn't grow with you? And that, again, something I said earlier, which is talk to the experts, because CPS papers can be written in such a way that it won't lock you in or paint you into a corner for future considerations. I think that's very important. This is an area where even I don't claim to be an expert, Tim, and I've been around this industry for over 20 years. There are specialists in this that you really need to talk to make sure that you don't have CPS problems.
Right, and we do have certainly our share of them here at Sectigo. It's just not you and I, Jay, because we focus on different things. Revocation checking. We've already talked about revocation. Revocation checking doesn't help, or revocation doesn't help if you don't know if a cert's been revoked.
Yeah, I would say there are some use cases in IoT, for example, where revocation isn't even possible. Therefore, you have to make the decision of having very low term lengths for your certificates. We talked about that earlier. But certainly, revocation checking, especially in private trust, if you're not checking those certificates, they're essentially long-lived certificates. And therefore, that term problem we talked about earlier, it becomes the equivalent problem.
Yeah. I don't really have anything to add to that. And then the public-private certificate, these two, again, 16 and 17 kind of go together. Public certs and private certs, they have their own individual advantages, right? Public certs are essential for certain interoperability scenarios where there's just no other way, or for services that reach outside of your own walled garden. Private certs, though, can be much better assets when you're confident that you can stay in the walled garden, because they give you more freedom and more control. And people don't always think about which one is preferable. Rather, they just do what they're used to, do what they did last time, do what's more convenient, do what's more available. That's one of the things we definitely see.
Yeah, Tim, I would say, I think the real quick rule of thumb here is if your use case utilizes a web browser of any kind, public certs might be a good idea in order to be able to avoid error messages, warning messages within the browser. For every other use case, the public trust is kind of a misnomer, because a lot of times when you might think you might need a public trust, what you really need is a trust model that effectively allows a multi-vendor ecosystem. And so you think of it more like a walled garden for multiple vendors. And that could be hundreds of vendors,
Yeah.
hundreds of organizations, hundreds of partners, but not necessarily public.
Yeah, we just on our podcast we just had a guest, the chairman of the SunSpec Alliance, which is a clean energy consortium, and he talked about how there are hundreds of technology providers inside of that single ecosystem, and they all have to be interoperable. And so that's where, if you have to use private certs, that's where you need to make sure that you give this stuff some very careful thought. And that's again where you should ask yourself if public certs is perhaps the way you have to go.
It's pretty black and white, but Tom gave a really good podcast.
Yeah.
That's one worth listening to for sure.
Yeah, for sure. All right. Problems with visibility. And by the way, you'll see 21's the last number. So this is the last of our 5 sections. Okay. And again, those first two kind of go together. Rogue certificates. What we mean by rogue certificates is somewhere in the organization, someone is working on a project that is being financed by some kind of internal customer. Let's say it's the marketing department. The marketing department says, I have an idea for a great new service. We're going to do really well with this. We're going to sell lots and lots of stuff. And they go out and they hire a development firm, and the development firm puts things together and they look at it. It's all great. And they stand it up. And one of the things those guys do is they go buy certs. So they buy some 1-year certs and they slam it in. And you stand up your service and you are a genius, and it's usually successful. And so 365 days later, this is an essential part of our revenue stream. And one day it's not working. And people are panicked and people are in trouble. Why? Because there were some certificates that nobody knew about, that never were on the roadmap, or never visible to the office of the CIO or the CISO, and suddenly, bang, things are down and people don't know why. And this happens a lot.
I would say, Tim, a lot of customers will initiate certificate discovery, which is a modern capability of a good PKI.
Right.
And they'll run it at the beginning. And then they think, well, I've got it. That's it. We're good. I think what you've just argued is that it might be a good idea to do it periodically, to see whether or not some rogue certificates have shown up within your organization, because it is a possibility.
Rogue certificates creep in all the time, and when they do, you have outages. And by the way, there are other scenarios, like an M&A scenario, right? I acquire a company. How do I know that I know about all the certificates in the company I acquired, right? And I just spent a bunch of my hard-earned money for their revenue stream. I don't want that revenue stream breaking because certificates expired. So yeah, rogue certificates, I think we understand that scenario a little more, but there's also a rogue CA scenario where the exact same thing happens, but it happens with an entire CA and all of its leaf certificates.
Tim, I think I mentioned earlier the visibility problem of Kubernetes clusters having CAs. Unless those are part of your governance program, unless you know what CAs are being issued, what's their key lengths, if they're being revoked, what are the policies, then I would consider those to be rogue CAs. And I guarantee this is number 19 on the list, but this might be number 1 on your homework list today.
Right. We'll get to your homework list. So exactly. And once again, this could happen through internal skunkworks projects. This could happen through, a diversified set of internal customers off using their own development teams or their outside development firms. This could happen through M&A. These are all scenarios where this can occur. And, I'm going and I'm standing up new machines and they're not working, and I don't know why they're not working. And it turns out at the end of the day, they're looking for a route that I didn't know existed, right? So that's a real thing. We see it. Future use case planning. There's a lot of here and now in people thinking about digital certificates and CAs and PKI, rather than asking, what do I need to look like in a year or 5 years?
Hey, I'm setting up a Microsoft CA because 100% of my employees at this very moment log into things that are connected to Active Directory. Hallelujah, I'm good to go. Fast forward to today, you now have the cloud, you now have operating systems that have nothing to do with Microsoft stack. You now have burgeoning technologies that are all over the place, distributed, not Microsoft operating system, and you didn't plan for any of it. And that's a story of the near past, but I guarantee the same kind of mistakes are happening today because the future is only going to blossom that much more. The proliferation of technologies in the near future will be more than we've ever seen.
Yeah.
Are you planning for those unknowns?
All right. Your environments are going to get more complex. Repatriation is going to become more common. The total number of systems involved is going to go up. The amount of DevOps is going to go up. The role played by mobile devices is going to go up. All of this is just going to make things more complicated.
Are you going to extend trust to partners in the future? Are you going to be dealing with the multi-vendor ecosystem? Are you going to have trust models that did not exist today? Are you going to split product lines? Are you going to do M&As in the future? All of these things are extremely important when thinking about trust models that you're building today and technologies and trust models that you're going to want to be using in the future. Don't paint yourself into a corner.
Yeah, absolutely. I mean, it's funny you just brought up the M&A one. That's such an interesting thing. Like sometimes when somebody has to spin off a business, all right, we're keeping this, but we're going to take this part and we're going to carve it off and we're going to sell it to someone else. And disentanglement there becomes really, really hard, especially if it turns out things like, well, they're all part of the same CA infrastructure, and suddenly they can't be, right? So for sure. Failure to stay current on cryptography. We kind of referenced this one early on, but crypto is changing. For example, I mentioned earlier, quantum computers are probably going to are soon to render RSA and ECC obsolete. We're going to have to go to completely different crypto, right? And completely different cipher suites. And so if you are running your own PKI, you're taking on an obligation to know what is cryptographically sound and what is not, and staying current.
Again, for the homework list, it is time to get your hands dirty in 2021, 2022 on quantum safe certificates and on hybrid certificates, which will help the agility of moving forward into that world. It is time to get your hands dirty with that now, and that's something we can help you with.
Absolutely. We're happy to help you with it. So the final point, so that's it. That's the 21. So what are you going to do? So what are you going to do now? You have this this presentation. It's also available recorded, so you can go back and look at it again. This is what we recommend you do. First of all is review this list. Go back and look down the list of 21. That's why we gave you a specific list, why we organized it. And think about which one of these potentially applies to your organization. And then we suggest that you make a project where you go to your internal SMEs and have them evaluate your practices in light of these common pitfalls, so you can identify things the easy way and fix them before you identify them the hard way when stuff stops working. And this is something you can go do, you can go work on right now.
Well said, Tim.
So we did mention, allude a couple times, Jay and I do run a popular podcast focused on the PKI and security space. It is called Root Causes. You can find it on SoundCloud, Spotify, iTunes, and a bunch of other places where you may listen to podcasts. Just search for Root Causes PKI and it'll come up. You can also just find episodes directly on the Sectigo website. We have recorded more than 150 episodes, and we cover all kinds of matters, digital certificates, PKI, and related topics, and we would love to have you join us. So with that, I think I will thank you for your time. We've been answering questions in chat throughout the session, and if there are more questions, we will continue to answer them. Thank you.
Thank you.